And that's finished. So we're live now. Welcome to our third session of our Biocontrol Technical Workshop series. My name is Alison. I'll be your moderator for today's session, and I'm joined by 4 experts to speak on the selection and release of parasitoids and predators for fall armyworm control. We also have our technical webinar expert from Grow Asia, Pranav, joining us. So if you have any issues, he'll be able to help you out with getting on and off the platform. So here is what we have in store for us today. It's a very busy agenda again. It'll be split into 3 key presentations from Dr. Salam, Dr. Barr, and Dr. Lee from CAS. Just before we start, I want to run very quickly through how to use the Zoom platform today. The key message today is that you have the opportunity to ask lots of questions to all our experts, and I really encourage you to do so. They are really looking forward to hearing what you have to say and also to hear what questions you have. And also, this is a good chance to actually share your research or your ideas in the chat box. The main way that you ask questions today is to use the Q&A box. So we really encourage you to ask the questions in the Q&A box and leave the chat for those comments, the sharing the links, highlighting important points, saying hello. And please say hello. It's great to hear from you and which country you're from as well, or organization. If you have a chance to rename yourself under more, you can do that there and just put your name and organization if you have one. This is just a reminder, this is our third session of a 6-month Biocontrol Technical Workshop series. This series is hosted by Grow Asia under the ASEAN Action Plan, but it's supported by experts and organisations across the world. Participation is open to all interested persons across Southeast Asia and beyond, and we really want to hear from you. You can also take part in a discussion, online discussion at the link below, and I'll put that in the chat box later on. And just to give you an idea that we've already had session 1 and session 2, our next session on the 4th of March will be on biopesticides. So we're going to have a little bit of a change from the world of parasitoids and predators and enter into this new world of biopesticides. So I encourage you to participate in that as well. Now, I'd like to introduce Dr. Muni Muniappan, Director of the IPM Innovation Lab at Virginia Tech. He's going to give just a brief introduction. And what we thought today, before our lineup of speakers, I really wanted to ask Muni a few questions. Some of these questions are ones that we have that keep coming up across our series. So this session is about the selection of effective fall armyworm parasitoids and predators for mass production and release. And I know that Muni has been undertaking a lot of work in this field for many years. So I'm going to ask Muni here if he had to give 3 top tips to researchers in Southeast Asia related to how you select fall armyworm parasitoids and predators for mass production. What would those top tips be? Muni, I'm putting you on the chair, the hot seat here. You just have to unmute yourself.
Thank you, Alison. Well, good morning or good afternoon or good evening, depending upon where you are joining this webinar. Yes, how best to select a fall armyworm parasites or predators in the Southeast Asian or in the tropical countries in Asia or Africa. One is you survey your field, maize fields, and collect the eggs and larvae, incubate them and see what kind of parasites are coming out. Then try to identify the parasites and also start checking how effective they are or how common they are. Then you select the ones that are easy to rear. From the literature, you will find out, say, Telnomus or Trichogramma is easy to rear. Then easy to multiply in the lab. So that is the one, those are the ones where you should concentrate on multiplying in the laboratory. And thirdly, make sure they are effective ones in parasitizing fall armyworm eggs or larvae. So one is identifying in the local conditions. Second, selecting the easy ones to multiply in the lab. And third is making sure they are effective.
Excellent, thank you. So there's 3 top tips for people to start off with. Keep that in mind as we go through the examples with our experts. Another question here that we often have is, Mooney, how economic is it to mass produce and release fall armyworm parasitoids and predators for fall armyworm control?
Follow. Lots of work has been done in Central and South America on rearing the egg parasites of fall armyworm and releasing them. Dr. Cave in Honduras, some years back, he did lots of work on telenomas, and he has published a very good article showing the economics of production of this parasite and releasing in the field. And also very recently, there was an article published in the Entomology Today. It's a journal published by the Entomological Society of America. In that one of the Brazilian scientists said, if we produce Telnomus remus on the Coursera eggs, it is 50% cheaper than producing on the fall armyworm eggs. So there are different methods to look into how cheaply or efficiently we can produce these parasites. Another, this is producing the parasites in the laboratory and releasing in the field is what we call as augmentative biological control. And this type of biological control is very commonly used in the greenhouses in Europe and Canada. It's used in the field conditions vary, but like I said, in Central and South America, it is used, this augmentative biological control is used for control of fall armyworm. Another advantage with this is all the money spent in producing these parasites in the country, it stays in the country. Unlike in the case of pesticides, if the farmers buy the pesticide, especially in the developing countries, most of the pesticides come from outside. So 75% of the money spent on the pesticide go outside the country. But in this case, the advantage is not only the money stays in the country, and also we end up developing the capacity of the scientists or the technicians, and also building the capacity of the local institutions in this case.
Excellent. I really like that last point about developing the capacity within the country as well. I think that's very important, and definitely something that the ASEAN Action Plan is hoping to really focus on. In your introduction in the last session, you put up this slide and it looked at sort of the model for rearing and release of fall armyworm parasitoids that you were developing as part of the IPM Innovation Lab work. We had a few questions about this, and I guess the questions were really around how effective do you think this model has been? And I know that COVID has sort of put a bit of a stop on your rollout of this, but what is your experience has been so far? Does this work for predators also? And in which countries do you have examples of farmer cooperatives or the private sector part of the model involved in this type of work?
This model I developed when we in 2019, when we started to work on the fall armyworm egg parasite production and release in Kenya, Tanzania, and Nepal. Of course, when we started to implement this in the field, then the coronavirus came in early 2020. It kind of delayed our work. We were not able to go to the field and do this work. So this model, basically what it says, it was of course developed for the IPM Innovation Lab. So we worked with the local governments, and we recommend a central nucleus laboratory be set up in the capital or wherever there is a government laboratory exists in that country. Then that laboratory will be producing the nucleus cultures of the local parasites, the trichogramma or telenomus or abrobrochon, whatever they select to rear. Then we also try to identify satellite laboratories in the provinces of the country. So the satellite laboratories could be a laboratory in the university or a government laboratory or a private company or a cooperative or commodity groups. Like in India, several sugarcane factories also produce these trichogramma parasites and supply them to their cooperating farmers or farmers who supply sugarcane to them. So it varies from country to country, but this is the model that we are trying to, set up in the countries where we work.
Excellent. Thank you so much, Mooney. That was actually very useful information. And I know they are questions that were asked a lot in the last session. I'm sure even this session they would have been asked as well. And that's given us a really good guidance and introduction to today's session. So thank you very much and for your help in convening and organising this this workshop and the last workshop. We really appreciate it. Thank you, Mooney.
It was my pleasure.
Thank you. And now I'd like to introduce our first speaker today, Dr. Bhattavatsalaam. And I'm not sure if I've sort of said that with the how I should have, but please correct me. From ICAR, the Indian Council of Agricultural Research, National Bureau of Agricultural Insect Resources. He'll be speaking to us today about the selection of effective fall armyworm parasitoids and predators for mass production in India. And it's a pleasure to have you with us. You have a huge amount of experience in this area, and I believe I saw you speak last week in a webinar session there. So it's a delight for me to hear you again speaking on this specific subject. And I'd just like you to ask you to share your screen, and I'll stop sharing mine. And Dr. Lee, you can turn your camera off if you would like now, just while Dr. Bhattavatsalaam actually speaks. And once you have loaded and you're ready to go, please start.
Are you able to see?
Yes, excellent. Thank you.
Yes. Can I start?
You can start.
Good morning, good afternoon. It's morning in India, 7 o'clock, around 7:30. Respected Dr. Muniappan, because he is like biological control father for Indian people, especially. He's a great inspiration for each of one of us. So all the other members. So I'll be presenting a small report of the management of fall armyworm, especially the parasitoids and predators for production in India. So I just a small introduction about the corn production in India. So we call it as maize in India. So we have about 9.47 million hectares. And of course, our productivity is very low. We have up to only 3.12 tons per hectare. And this is the third major cereal after rice and wheat. And it is grown throughout the season. It is Kharif, we call it in June, July, it is sown. And again in Rabi, we have in October and November. And sometimes it is also taken in the summer. Usually the Kharif field, that is June, July, is little less, but the Rabi yield is very high. And this is the usage pattern. Usually, most of the time, it goes only for poultry production. So this is mostly poultry production. Again, we have the direct consumption is about 20%, and the rest is going for food, beverage, starch, and cattle feed. So fall armyworm entered in India in 2018. First, we noticed here. This is the Karnataka where we are located now, and within a span of maybe 1 year, we have seen almost it has gone up to this level now. Only these two states are left out. So if you, it is not updated. So we have now seen records up to this place. So only these two states are left out now. Of course, this is, I don't want to repeat this as all you know again, but the crop damage which usually we see in other countries is not much. And of course, the alternate host is sorghum, though there are some reports that it is coming on cotton and sugarcane like that. And sugarcane we have seen some extent, but cotton and rice, some stray incidents have been noticed. Of course, not to call us a pest, but the egg natural enemy parasite is very high. We got almost like 15 or so. The Telenomus remus, which is actually the parasitoid which we have imported in 1960s for the management of Spodoptera litura and tobacco, it has started establishing on this. We have already noticed in different states, And again, Trichogramma species, again, we have seen the Trichogramma pretiosum as well as the Trichogramma chilonis, we have noticed. And these are the egg larval parasitoids, chilonis, which already we have identified as Formosinus. Of course, one more is yet to be identified. This is also there. This Braconid parasitoid, Coccidium, is doing very well, especially in Andhra Pradesh, the neighboring state. There they have recorded a parasitization up to 40 to 50%. Of course, the Cotesia is a larval parasite. This is also seen to some extent. So Campylortus chloridae, economonid, it's also, we have seen some places we are also getting this parasitation. And Eryborus, again economonids. And these are some of the larval parasitoids which we are recording. Though it is not, the parasitation is very high. I'll share the next slide. I'll show how much is the parasitation. And again, the people parasitoids, Trichomalapsis is also there. Then this is the earwig. This is having very good parasitation, predation. Again, one record is on the coccinellid to be the predator of this egg and young larvae. This is the data which we have recorded in one of the states, that is Karnataka. So you can see Trichogramma, the parasitation is up to 23%, and Telenomus is up to 8.7%. And of course, Chilonis is almost like 4.9%. Cotesia is all very low. Again, Campylortus we found up to 6% parasitation in different regions. This is one place it is 2.94. And again, Chilonis is also up to 6% parasitation. So this is the record which we have found in the state where we are living, that's Karnataka. So these are the effective egg parasitoids which we have seen. So already I have told Pretiosum we have imported from 1964 from USA, and Telenomus again we imported in 1963, and this both have excellently established on the fall armyworm eggs. So here, this is the mass production. We usually rear the Trichogramma on the Carcera. This is the rice moth. So here, this is just to show how we are doing it. So usually we have small boxes where we have the sorghum grains. This is the size of the box. So this is the boxes. So this is our rearing unit where we have the production of all these Carcera cephalonica eggs. So we just inoculate that with the eggs of Carcera and keep it for about 40 days, and the moths start emerging, and we have a device to collect that directly into a bucket. And this bucket acts also something like inside there will be one more bucket where we have the we use it for the adult rearing of Carcera. Just we keep it, and this will have windows, so we can see how much they are there. And below we will have a sieve, so all the eggs will be directly collected into this. So we need to we did not worry about that because eggs will be directly collected in the paper because we have a sieve below that rearing cage. And so once the eggs, this is the eggs we have collected, and once the eggs are collected, we go for UV radiation for about like 30 to 45 minutes. So these eggs are again used for the parasitation. So here we have a small card type. Still we use the traditional type of egg cards. So here we will sprinkle about 1 cc of Carcera eggs, that is almost like 16,000 eggs, and this we will keep it along with a bit of already parasitized egg. So in the balloon we just keep it, and it automatically parasitizes, and we get very good parasitation up to 90%. So this is the new method. Instead of the balloons, we also have this kind of rearing boxes because the production is very quick. So the more number of eggs we can able, no more number of parasitoids we are able to do it. So this is the way we are using. Our production is, so this is the glimpse of total or mass production method. So this we have almost like 150 to 250 cc of eggs. That is, you can imagine the production unit of our mass production unit. So this is our capacity. Sometimes we can increase up to even 300 cc per day. Depends on the market and again demand. So this is the egg larval parasitoids, the Chilonis formosonosus. So this is also, so these are the other predators. This is the pentatomid predators are very good in that. We also found that naturally they are feeding on the larvae of Phalameum. This is the earwig, which already we have mentioned about it. So this is also known as the egg predator. So so this is the production unit which we have started establishing. So we have started rearing the Chilonis formosinus, and this we can. This is the attempt we have made, and we are able to collect it. This is again we are rearing on the Carcera cephalonica. So this is a simple way which we have done it. So this is about taking about 20 to 25 days, and the parasitation is 10 to 19% and 45 to 50% adult emergence we have noticed in the laboratory. And again, when we are using in the Carcera, it is giving more parasitation. So this is a very good message for us, because we can also able to use Carcera for rearing this. So of course we have started rearing on that, and we are able to supply to the farmers need based, but not to that extent which we can call it as a mass production. Again, this pentatomid predator that we are able to rear it on the egg, again on the Galleria as well as on the Carcera cephalonica larvae. We have started using that. Of course, this is the method which we have taken. The eggs are taken, and the first instar they are kept it along with the eggs of Galleria or Carcera, and again after some time we rear it individually because they have cannibalism. So here, so we are able to produce very good numbers. Again, the production has to be increased, but this is the total biology and life stable studies we have done. So this is the total life cycle. So it takes the first instar 3 to 5 days, second 3 to 4 days, like that. All the 5 instars it completes, and we get a good number of this one. So this is some studies which we have done it to show which is the best host, whether the Carcera or the Galenia. So we found it's almost same, because if you see the hatching rate and other things, so we come to the conclusion that both the larvae can be easily used for rearing, though there is some Galleria is a little better choice than Carcera. So in summary, we say this is the fecundity of almost 350 we are able to put it on Galleria, and again 310 in Carcera. So if you see the other parameters, so Galleria looks a better this choice as a host. So based on these studies, we are already recommending in the field. So as I told you, our production is very good, though it is not comparable to other countries. Still, we are able to produce a good number of Trichogramma. So this is the cost involved when we are using the Trichogramma Proteosium or Chilonis. Actually, though Proteosium is known to be the parasitoid, which is already recorded in literature, we found even our own indigenous Chilonis is able to do the same kind of job. Even in the field also, we are getting natural parasitation by the Chilonis. So we are now started recommending only Chilonis. Of course, Proteosium also we have the cultures. So if you use, we release about 4 releases at weekly intervals from 20 days old crop. So each card is almost 16,000 eggs, which is costing almost like 100 rupees. So if you say almost 4 cards, you'll be using so 400 rupees and 4 releases. That comes to almost 1,600 rupees, which is coming to almost like 23 US dollars. And again, Telenomus we recommended those of 4,000 per acre, and again 4 releases. So it comes little higher because production of Telenomus is little difficult compared to Trichogramma. Of course, we will take the cue from Dr. Muniappan that we can also be able to rear it on the Carcera, but we have never attempted on Carcera Telenomus. So we used to rear only on the Spodoptera litura eggs or Fergipoda eggs. So we are good able to produce and give it. And the others we are unable to work out the cost because it is initially it is still at the initial stages. Maybe we can think it later. Maybe in the coming seasons we will be able to give about the cost of production of all these other agents. So, regarding the supply, what we call it as CAPMC, it is the Government of India production units. They have in almost all the states they have that units, and they are able to produce and supply Carcera cephalonica already. So it is not a difficulty. And again, the state departments also they have very good rearing units, especially in southern states. So some KVKs, which we call it is under ICAR, they are also able to mass produce. Especially, we don't have any problem in the trichogramma. There are some private production units also. So, so we may have to only scale up and give some more capacity building and see that it is taken over. So that will not be difficult. So already we are making efforts for that. So other apart from that, what we found is, as I told you, other predators and parasitoids. So what we thought is the parasitation is a little low. So we thought we are not making any augmentative releases. So wherever people ask only we give. But what we have seen is when we combine these egg parasitoids and again the microbials, we have got an excellent results. This is the IPM trial which you have done. So this is we have the our own strain, that is BT25. So this we have, it is already shown 85% of increase in the pest incidence. So these are some of the data which we have got from different places. So it ranges from 70% to 76% pest incidence is reduced. So this is again we have Metarhizium anisoplia one strain MA35. This is also giving more than 68% mortality. So this already we have tested in different places in and around Bangalore. So we have got from 55 to 80% reduction in the pest incidence. So again, we can also see in some places we also see the natural infection of one more known as the Beviria felinae. Of course, the mass production we have not attempted. So natural incidence of virus also we have seen. So this is the NPV, that is the Podoptera falciparum virus. Of course, this still we are trying to produce in the maximum. So what we have done is, this is our evaluation trials. So we have got almost like 82% reduction in pest incidence when we use the NPV Podoptera falciparum virus. So nematode also we have used Heterodapteris indica. One strain is our own. So we have used at the rate of 4 to 6 kgs. So we are not going for the whole application. We are only putting in the holes, not the whole broad. We are not broadcasting. So it is almost like on par with our insecticide treatment, that memectin benzoate. So combining all this, we have made some trial with the APM. So we used pheromone traps 20 days after transplanting at the rate of 10 to 15 per acre. Then again, we release the Trichogramma pretiosum or colonis. Then one spray of neem oil, and again BT we have given one spray, and again Metarhizium anisoplia one spray. So with all these combinations, we have done in different places. One at initially we have done in Gauri Badnur with a small area of 1.5 acre, but later last year 1920 we have done almost like 30 acre we have shown. So this is the control plot, and you can see the field which we have used all our biocontrol inputs. So this is the small trial which we have done. So based on this result, we have got an excellent result. So this year in 2019-20, we have shown to the people, even in the sweet corn, you will be able to manage this Palamivum without any insecticide spray. Only thing is the number of releases were a little higher, but the farmers were very happy because they were fed up with the insecticides. So they have also learned that without any insecticide, easily you can manage this pest by using only biological control inputs. So this is the data which we have got. So you can see the number of egg masses, and again, you can see in comparison with our farmers practice. Farmers practice is not without treatment, it is chemical treatments. This is our own IPM trial. You can see on different dates we have collected the data. So you can see how the difference comes after 60 days after treatment. So in conclusion, we have showed the natural enemy complex. Of course, natural participation on the X is very high. We have seen the biocontrol agents like for especially the fungal agents and bacteria, they are going very good. Even the MPEPN also is very good. So one integrated manage involving this along with 2 sprays of neem to be very, very effective. So one thing what I want to tell the farmers is don't abandon the crop, because this is initially you may see the infestation is very high, but the plant is able to survive. And now don't use synthetic insecticide. And of course, the need of the hour is that we should have more of mass production units. So that is we are taking up this one. We are also trying to uh, take the help of private entrepreneurs as well as the government of different states in India to improve their production units, so that the supply will be easy and it will be very quick, and we should be able to adequately manage this without the insecticide help. Thank you very much. Thank you very much. I think I have done my job.
Excellent. Thank you so much. You've done a very good job. And there's so much detail in that presentation. It's difficult to know where to start to ask questions because there is so much in that presentation. So thank you so much for that. I've got quite a few questions here. One of them is how do you best communicate to farmers about these different control approaches? What is the best way that you do communicate to farmers? How do you do that in the most effective way? Do you have to do a lot of education?
Yes, yes. So already we have taken the help of CABI, and under that CABI, I showed you that 30 acres of demonstration that was held in farmers' field only. It is not our own experimental field. So we did that demonstration at almost like 25 farmers were involved in that. We have because here are all small holding farmers, they don't have much area, almost like 0.5 acres to 1 acre or sometimes 2 acres, that's all. So we have shown that demonstration in their field with our own inputs, and we have after the when the plants are about to be harvested, we had a field day at that village. We called all the farmers and the farmers from the surrounding villages also. We also called the media. So we also had a small field day meeting with the involvement of State Department of Agriculture. Deputy Director was there, Agriculture Officer was there. So in their presence, we showed how effectively we have managed this FAW through our biological inputs and what is the cost benefit ratio also. So they are very happy because the input for insecticides is going very high. But when we use these biological inputs, they are very, very happy because it is maybe not even 40% of the cost which is involved for insecticides. So we had one program in last year, I think November we had it. Because of COVID, we had restrictions. And of course, previously we have conducted so many awareness meetings about these biological inputs in different states, and especially in our neighboring states. We have also brought out some publications which are already available on different languages. We have, of course, as you know, India is more than 100 languages.
Yeah.
So we have already made almost 5 languages. We have already made these brochures and the extension bulletins, which are already available in our on-site. So that is the way we communicate. Of course, farmers are very receptive. This actually, I told you, sweet corn, we were not hopeful that we will have some achievement, because last year when we did, farmers didn't want to take it because the cost of the seed itself is very high for them.
Yeah.
They pay almost like 20,000 rupees. So it's almost like, I don't know, how do you calculate, divided by 70. So that much cost it is. So they didn't want, because they want to be very careful about the crop. So they every day go on almost alternate days, they are spray. But
Yeah.
these farmers, which we have taken up now, sweet corn, they are very, very much convinced about that. And again, I think we will be spreading to other villages nearer to the area, which already we have proved. So this is almost like 70 kilometers away from Bangalore. So this year again in the Rabi we have taken up some trials. So this is all going on. So in that way we are propagating. Of course, once the COVID situation relaxes, we are starting with the help of CABI. We will be doing this in the other states which are having this problem. So maybe the neighboring states will be spreading the message. So,
Excellent. I really, that's a great answer. There's also lots of valuable tips there for others, but I like the variety of communication methods you're using, drawing on local media, but also drawing on other organizations, using it in different languages. I think that's very important. I think what you mentioned about that, this was my next question actually, that the cost effectiveness of this, you're saying that it's a lot cheaper to do this than to apply conventional pesticides. A question then, is it a lot more effort though to apply these sorts of strategies for the farmer? Does the farmer, I mean, the farmer has to do it maybe every week or I think it's every week or something, or how much effort exactly does it require of the farmer?
I didn't get that question.
How much effort does it require of the farmer? Because it's obviously quite cost effective, which is good. That's interesting for farmers. How much extra work does it require of the farmer?
Actually, the application of this biopesticides, they have to spray the metarhizium and all these things, they have to care because this is done by them. Maybe if any labor in this involved, they have to bear the cost of the labor. Otherwise, they themselves do because the labor is very costly in Bangalore and other regions. So the farmers themselves do the spraying and the release of egg parasitoids, everything. Of course, we train them. Our own group, already I put about 4 or 5 people, all of them are involved. They go and give them initial training. After that, we regularly we have a contact farmer. We give it to him, and he will distribute to the other farmers. And once we teach them how to release, and they go on releasing it. So the involvement is there. The application is taken care of by them. They only have to.
Excellent. And that sounds great. But and also, so that means that they have easy access to all those tools.
Yes.
Oh, great. I did have a question, but they're being answered as well while I'm speaking. I do have another question around so this relates to what we've just been talking about. This combination of control approaches, I think, is very interesting, and this sort of more holistic IPM approach. You had this 30-hectare field testing station, I think, or experiment. How easy is it, therefore, to scale that up across many, many farmers? So the type of approach you've just been talking about, is that scalable?
Yes, yes. Trichogramma, initially you need to have the production unit for the laboratory fixatious host, that is Coursera. We are trying now, of course, some other farmers are coming up, but the production of our fungal pathogens is very easy. So we can easily rear it on the boiled grains, sorghum or rice. It is easy, but the only thing is quality control is very essential. So we tell them because the number of CFU is very important. So that we also teach them how to do it. It is scalable. It is not a difficult one, especially the government organizations and some kind of micro and small and medium entrepreneurs. It is not a difficult job. They can do it, and we are trying to do it. And already we have sold some 2-3 companies about the metarhizium strains. So we have toxicology data for some of our strains. So those things they will be able to take up. And of course, they can use instead of the strain which I have mentioned, this it's already under the recommendation of our DPPQ, Department of Plant Protection and Quarantine. So it is scalable, easily scalable.
Okay.
And EPN, we have already sold the technology to more than 22 companies, entrepreneurs. So they are able to produce. So it is not difficulty. And again, we don't need any registration under our government regulations for the EPN production, and because this is beyond that registration, so it can be easily used.
Okay.
So EPN fungal pathogens easy, but BT already commercially it is available, so it's not difficulty. Mass production of trichogramma we can do, it's not difficult.
Okay. I've got two questions here, and then we're going to have to close. I might sneak in a third question, but just quickly here from Rika from URI. I understand individual farmers implement the release. How large of an area needs to be coordinated so that there's no pesticide spraying in nearby fields?
It's okay. Even 2 acres or 1 acre is no problem, because usually we don't see the drifting or moving out from the, because trichogramma doesn't move much. Hardly it moves within 5 meters or so. So it doesn't move to other fields. And maybe the farmers, if they somebody neighbors are spraying insecticide, we told our farmers to wait for a few days before releasing the trichogramma. So
Okay.
otherwise, I don't think we don't have that kind of mixing effect or interference.
Okay. Here is a question here. Without support from a local institute, is it possible for farmers to start any work in adopting biocontrol without initial release of natural enemies?
There are some, especially the trichogramma, which already I have given a table. This is the natural parasitation which we have seen. So if you can augment or if you can make efforts to conserve that, I think our IPM also says we have some kind of harboring plants or some refugee plants like that. So if you can do that, it is easy. Otherwise, it will take some time to have the natural control. Maybe if you have 2-3 seasons, maybe in the third season, you will see the natural management. Maybe incidence will be there, but it will be minimal compared to the first season you have.
Excellent. And just for everyone's attention, we will have a session on conservation biocontrol later in this series. I've got a very quick question here. And this will be interesting because we haven't had a speaker from India before, but this question is, fall armyworm really only a major pest on corn or maize?
Yes.
Have you seen much really on non-grass leafy or fruiting vegetables in India? Is there much evidence of that?
Yes, a recent report yesterday only I was hearing to one lecture. This also attacks almost like 10 gramineous plants. Most of them are weeds, including leucine and other things. So it comes on 10 crops, but not to that extent to be called as pest. But mainly we have seen it is a pest in maize and sorghum only in India. Though there are some reports in the early stages of sugarcane it comes.
Okay, excellent. Thank you so much. And thank you so much for that very detailed presentation. We need to move on quickly, but you may have some questions coming through on the Q&A panel there. And if you could help answer some of those via writing, we would really appreciate that. But thank you so much for joining us today.
Thank you, Dr. Allison.
Thank you very much. Okay, now it's my pleasure to invite our next speaker, Dr. Malik Barr. And Dr. Barr was with us 2 weeks ago for our second session, so it's really nice to see you again, probably very, very early in the morning where you are. But you look bright and happy and ready to present, so welcome. And just tell me when you would like to move to the next slide, Dr. Barr.
Okay, thank you very much, Alison, and good morning to everyone. So I'm going to share the work we did on the selection of fall armyworm parasitoids here in mainly on my lab here in Niger. So next slide. So then, as you all know, when fall armyworm was first detected in Africa, it was creating havoc, and then people were very concerned on how to manage the pests. But there was some people in the scientific community that thought that Muni was one of them, of course, who thought that because it's true that it's a new pest, but we can expect the pest to be associated with some natural enemies that were already available in the environment. So in fact, there are some related species such as Predatory littoralis, Exempta, and Exugia that are present in Africa, and who could share their natural enemies with the new introduced one. And as it happened in other system, new association was expected and predicted. And this, the work on natural enemies of fall armyworm has been facilitated by the fact that there was a good network of scientists from different institutions that were already interested in biological control. Next slide, please. So for selection of parasitoids, there are different steps that we have to follow. Of course, first you have to go in the field and scout for your natural enemies on your target pest, in this case, the fall armyworm. In case you identified good natural enemies, you have to develop a mass culture technique for those natural enemies. And this topic was covered in my talk last time. And when you establish a culture, you also need to test the effectiveness of your parasite in the laboratory first before going to the field to validate the effectiveness. Next slide, please. Next, please. I'm not seeing the next slide, Alison, please.
Alison, your screen is frozen.
Is it mine that is frozen or her?
No, it's actually mine.
It's
so
Alison's, yeah.
Let me just, I'm not sure why it's frozen. Here we go. Is that good?
Yeah, it's good now.
Excellent.
So
and just, are you seeing the back end or the whole presentation?
As in, we're seeing the back end. We
Okay.
just hit this
So I'm
display
just
settings change.
Excellent. There we go.
Okay, thank you. So then, for depending on the parasite you are looking for, if it's an egg parasite, you have to go in the field and collect the eggs. For the fall armyworm, you have to go to the field and search eggs on the plants. So here you have illustration of people in the field looking for fall armyworm eggs in the field. And when you have also your culture of fall armyworm, instead of going and look for natural laid eggs, you can also use the sentinel eggs techniques. So then you collect your eggs from your culture in the laboratory and you expose your eggs in the field for some days. And to avoid your eggs, I mean, when you are looking for parasites, you don't want predators to come and eat your eggs. So you can cover the eggs with a mesh to avoid predators to eat them. And after some days, you just take back your eggs to the field. You incubate them in the laboratory in vials. And when they are parasitized, so you'll see emergence. And the good thing with the egg parasites, usually they turn blackish when they are parasitized. So then you can see emergence of your parasite, and the next step is to get them identified. Next, please. So likewise, for larval parasite, you also go in the field, you collect your larvae. So make sure also to collect larvae of different stages. So don't focus only on the big larvae, the big caterpillars. So try to get the diversity of different stages. And when you collect your larvae, you put them on in the diet in the laboratory, you incubate them there, because in case they are not parasites, so you need them to continue developing. So you need to feed them. So then you put them on the artificial diet, you incubate them. When they are parasitized, so most of the cats will die, and you can see emergence of some parasites at the end. So then a parasite that emerged, the larvae parasite that emerged, just take them to the laboratory and to a taxonomist to get them identified. Next, please. So then with this work, we were able to identify a lot of egg and larval parasites in different places in Africa. For instance, in Eastern Africa, there was a new association with some Cotesia, Coccidium, Palexorita, and Carops, and Chelonis, like the species that the colleague mentioned in India. So this study actually was the first report of a new association of natural enemies of the fall armyworm in Africa, and it was conducted in Ethiopia, Kenya, and Tanzania by a colleague from ECP. Next, please.
Dr. Barr, I'm just going to interrupt you. I'm just going to stop sharing my screen and reload it. I seem to have a problem with the screen. So if you just wait 2 seconds,
Yes, sounds good. No problem.
I will do this. I need to. And I'm going to. I'm coming.
Okay.
And hopefully I'm just going to swap this. And I just want to ask Pranav, our technical person, is that good?
Yeah, now,
Yeah, it's perfect. Thank you, Alison.
I'm so sorry, Dr. Barr, because it's an excellent, so I'm sorry to interrupt you, but we're all good now.
Okay, so next, please. So then in Niger also we came with new associations with some egg and larva parasitoid, and the most common parasitoid that we came across were Cotesia, Bracon, Carops, Campolitis, and some tachinid flies as well. Next, please. And then we also collected Chelonis, which is our egg larva parasitoid, like the colleague from India just mentioned. And we come across also 2 egg parasitoids, Telenomis remus, which it was first identified as Telenomis, and then later on we were able to establish that it was a Telenomis remus, and another egg parasitoid from the Trichogrammatoideae family. Next, please. And you can also easily come across predators like ants. So here that's a picture where we spotted ants that were feeding on egg masses of the Phalamuum in our fields. Next, please. So here you have the new association in Ghana. So you still have the same common species that have been reported elsewhere in Africa: Cotesia, Coccidium, Bracon, Chelonis. And in addition to that, you have some ants like Phaidole and other ant species, predators. Yeah, that's it from Ghana. Next, please. And new associations were also reported in Benin and again Ghana. That's from another study. And they have the egg parasitoid Telenomus and some Trichogramma species also, and some Braconidae egg larval parasitoid Chelonis, and some larvae parasitoid like Coccidium and Cotesia, and other Carops and parasitoids. Next, please. So this one is a study from Zambia that also reported some parasitoids, and from the Braconidae family, the Ichyomonidae family, some from the Elophidae family, and some Tachinids. So then you have those species, the same species that were mentioned in other categories like Coccidium, Chelonis, and Carops. Those are coming everywhere in Africa. Next, please. So likewise, you have the situation in Mozambique with species that were also reported in other places. And except this Drino quadrizomula that was not reported elsewhere. Next, please. So then the most interesting information from the different surveys in Africa is the presence of Telenomis remus all across the continent. As you all know, Telenomis remus is an egg parasitoid that originated from the Malaysia Peninsula. So then it got introduced in Africa probably accidentally. And then now it's spread across the continent, and it is available everywhere in the continent now. Next, please. So then the question now, how to use the newly associated natural enemies. So there are two ways of using those parasitoids and predators. You can go with the conservative biological control approach to enhance the natural enemies that are already occurring in your field. And for that, you need to rely on habitat management practices to avoid pesticides that are harmful to your beneficial insects, and also use some agroecological approach that will enhance the natural parasitism. All the good friendly farming practices in that case will work for enhancing the natural parasitism. And this conservative biological control mostly it applies mainly for the case where you cannot mass culture your natural enemies. So in our case, I will say most of the predators and some of the larval parasitoids are very difficult to mass culture. So then you need to preserve them, conserve them, use good practices that will let them continue doing the good work they are doing in the field. Next, please. So in case you are successful in developing culture of your beneficial insects, then you can go for augmentative or inoculative releases. And this will apply mainly to the egg parasitoids that are most of them are quite easy to mass culture, like Trichogramma species and Telonomis. And you also have some Barconid larval parasitoids that can be easily cultured. The colleague from India referred to Chelonis that were able to culture in the lab. Some of the Barcon SP species also can be easily cultured. So those are the kind of parasitoids that you can use for doing the augmentative biological control. And for that, you have to multiply them in the laboratory. So establish a cost-effective mass culture system and release them in the field, and use also a cost-effective release technique. Next, please. So then here I'm showing you the different steps that we follow with when we come across Telonomus and it's one of the Trichogrammatoid species. For recommending which species to be used in the field, we first tested the effectiveness of the two species in the laboratory. So we give them different egg masses of the fall armyworm. So as you all know, the fall armyworm egg masses usually are well covered by a scale of hair, but it happened that in some cases, the egg masses are not fully covered. So then we use the different type of egg masses and we give them to the two parasitoids together or separately, and to see how effective they were able to parasitize the egg masses. So you can see from this picture here on the green histograms that the egg masses that are uncovered, so don't have the scale of the hair scales, are highly parasite as compared to the egg masses that are not covered, regardless of the Telonomis being alone or Telonomis and Trichogrammatoid together. But when you consider the species, you can see it on the right side here, the right histogram. So you can see that Telonomis remis is the most effective parasitoid, reaching about 80% egg parasitism as compared to Trichogrammatoid when alone with the egg masses. And you can see that when you put the two species together, it deters the effectiveness of Telonomis remis. Next slide, please. And level of parasitism is not the only thing that you should look at. You also need to make sure that when you parasite the eggs, the parasitoids are able to develop on it and produce progenies. This is because in that case, you don't need to go every 2 days and release new branch of parasite, you from the initial population that you release, they can multiply and continue developing in the field. For that, they need to emerge and produce viable progeny. So you can see here that the two parasites here, Telenomus cermis is the one that is producing the much higher progeny as compared to Trichogammatoideae. So then from that, we were confident enough to say that Telenomus cermis is a much is the most the best performing parasite in the laboratory. And then with that, we decided to continue in the field to field test Telenomus cermis. So you can see here the field assessment. So when you release Telenomus cermis in a given field and you compare it to a control field where you did not release Telenomus cermis, so you can reach over 60% egg parasitism in a release field compared to less than 15% in control field. Since Telenomus cermis is occurring naturally, that's why you have also some parasitism in the control field. It's not the parasite that you release that from your release field that came to your control field. Those fields were separate enough. There was no way for the parasite to travel from one field to another one. So it is the natural parasitism. So then what you do when you release, you augment that natural parasitism and reach the 60% as compared to the only 15% that you have in the control field. So you can see that in the field, you don't have any adverse effect on the development of the parasite. Parasite eggs were able to produce enough progenies regardless of coming from your mass culture or the naturally parasite eggs. So you still have good emergencies in the field, which indicate that Telenomus cermis is a very good, effective egg parasite that can be recommended for feed releases. Next, please. So then there was also some study in Kenya from the colleague from ECP that also indicated that Telenomus cermis can be a good one. You can see that in the field, Telenomus cermis is giving more than 70% natural egg parasitism. And you also have Trichogamma chilonis, that is a very good one. So those are indicative of the parasite that you can select for your mass culture and then recommend for your biological control. From the natural parasitism, the parasitism that give the higher parasitism in the field, those are the ones that you can pick for going for further studies in your laboratory and then go back for releases. So it's indicative of the effectiveness of a parasite. Cotegia ECP is also a good one, but you have to know how to culture it, which is not easy for everyone, and also develop an economic mass culture. So recently in Tanzania, where they came across a Trichogamma species also, Trichogamma mwanzai, which gave about 70% parasitism of fall armyworm eggs, which also indicative of the good performance of this parasite. So it's a parasite that also need to be tested further in the laboratory and then follow up with field releases. So then, as I said, from your naturally parasite eggs in the field, you can pick the most performing parasite and continue your studies in the laboratory and then identify the one you want to promote for your augmentative biological control program. Next, please. And when you identified your best performing parasite,
Dr.
you
Barr,
already
you
have...
just have 2 more minutes.
Okay, so I'm almost done. So then you go back to you have to release them in the field. So you have to develop a technique for releasing them in the fields. So usually we use the egg cut technique. So we parasitize the eggs in the laboratory and we put them in envelope and then release them in the fields. So depending on your crops, the species, and the level of infestation of fall armyworm in the field, so you have to release certain number of parasites. That one it's not something that is standardized. So you have to test in your context to identify the number of parasitoids that are needed in your field, in your context. Next, please. So regarding the economics, and the colleague from India also touched base on it. So trichogramma, they are quite easy to mass culture, and they are cost effective, and they have been using all around for centuries in many places for biological control. So those are the most effective egg parasitoid. Telonomys is also good, and Muni just gave you some pictures of the colleague in Brazil suggesting the use of telonomys, but for that to be more effective, you have to mass culture telonomys on Coursera X. Next, please. So then I will, as I said, for the recommendation, you have to go for trichogramma and telonomys. That's for my context. And you have to do the same in your context and test them, and then go with further studies and identify the most effective one. And for augmentative biological control, national program capacities have to be developed and established. I mean, the model that Muni just showed, we are using the same model here in Niger. We started with another pest, the millet head miner, and that's the model where we are also trying to push for armyworm using the farm cooperatives. Thank you very much, and I'll stop here and take questions.
Thank you very much, Dr. Barr. That was an excellent presentation. And the one last time and this one together is just a huge amount of information for all of our participants in the ASEAN Action Plan to take on board and learn from. A few questions here. I'm going to start with the same question that I asked our previous speaker, and it's really around how do you roll these sorts of control approaches out to farmers? I mean, what's your experience in Niger or in other African countries around farmer uptake of these sorts of control approaches?
Okay, thank you. I mean, I will, as I was just referring to in my last slide, we have a model that we have been using for another pest, the millet head miner. Mm-hmm. So there was a parasitoid that we have been rearing in our lab that was effective. We tested the parasitoid in the field. The farmers were happy with the technology, but the challenge was how many parasitoid do we produce and how many do we scale out the technology? So then we went to the farmers, we discussed with them, and then we decided to set up small, laboratories in their own condition. So cottage parasitoid production by the farmers themselves. So then we identified some cooperatives, farmers cooperatives that were willing to test it. And we started sometime, if I remember well, it was in 2017-18. And now in Niger, we do have a few numbers of farm cooperatives that are producing this parasitoid. It's Biocontrol, Biocontrol. Mm-hmm. So, but for them to continue doing that, because the most challenging for them is to maintain the culture all year round.
Yeah.
So what we are doing, since we have been trained on how to do the culture, so what we do every year, we just give them a stock of Bacon for them to multiply. Okay. And have enough numbers and prepare the parasitoid, and they sell the parasitoid to the fellow farmers within the cooperative.
So that's how it's the financials there is that they sell on to the farmers, and that pays for the activity, the cooperative activity.
Yes, and we were able to show that how effective it is and how cost effective it is, how beneficial it is. There was one paper that we published in crop protection that showed clearly that it is beneficial to all of them.
And how do the farmers, do they like using this approach? What's your impression there?
Yeah, in the case of the millet head miner, actually farmers are actually left with no option, because millet is not a cash crop. Okay. So then they are not used of using pesticide on millet, because it's not beneficial to use pesticide on millet. So then that's the only option they have. Either they use this technique or they just pray God and wait for the crop to be protected.
Okay, so for fall armyworm though, it's a bit of a different story. So keeping that in mind, how do you think you can get farmers to uptake these sorts of approaches for maize?
Yeah, for me, it has to be, we have to showcase the benefit of using the parasitoids. And since we are in the context where we are already using biological control for another crop, so those are the kind of example that we have to give to them and to convince them to move on with this approach instead of relying on insecticide. That most of the time, I mean, even the access and the cost is a bit challenging in this area, and you don't even have any guarantee on the quality of the pesticide that are on the marketplace. Those are the kind of message that you need to use to convince them to move on to this, to adopt the biological control approach.
Okay. The last speaker also gave an example of where you sort of an IPM approach where they were looking at combining different biocontrol approaches or control measures. Are you doing that in a similar way? Parasitoids with, say,
Yes, I will. I'm
BT or EPM?
I'm currently interested. I'm working on host plant resistance, especially yes for sorghum, because you know that fall armyworm also attacks sorghum. So then, for what we are, I mean, it's in the early stages. When we manage to get some sorghum varieties that are resistant to the fall armyworm, then we'll recommend those varieties. And as you all know, host plant resistance fits well with. It's very compatible with biological control. Then the two can go together.
Okay. One question here, how many parasitoids are enough to cover 1 hectare of infested field, and when? I guess that depends on the context, but a rough idea of how much you would have to release for 1 hectare coverage?
Yeah, according to the existing literature, it ranges from 20,000 to 200,000 per hectare. Yes.
Okay. And I've just got a quick question. Just when you showed the difference of effectiveness between Telenormus rumus and the trichogramma together, but one, I think the Telenormus rumus was much more effective in your trials. When you showed them together, it was a lot less. What's happening there?
Yeah, it's mainly because trichogramma was not able to pass the barrier that you have on the egg masses. Yeah, because it's difficult for them to get through the egg masses the cover that the fall armyworm put on the egg masses. Trichogramma find it very difficult to get in and lay eggs. These species, I'm not saying that all the trichogramma, some trichogramma species are quite good. Trichogramma chilones and Petiosum, they are able to pass that barrier, but this particular species was not able to pass the barrier.
Excellent.
That's
okay.
Why.
Thank you very much. Thank you very much, Dr. Barr, and thank you very much for your presentation. And we're very pleased to have had you join us. Thank you.
Thank you. Take care.
So I'm now very pleased to introduce Dr. Li from the Institute of Plant Protection of the Chinese Academy of Agricultural Sciences. She specializes in plant protection, insect rearing, insect physiology, and she's here to talk to us today about mass rearing and release of green lacewings against fall armyworm. Dr. Li?
Hi, Irene, can you hear me?
Yes, we can hear you very well.
So I start now. Okay, good morning, everyone. First, it's my glad to be invited and make this presentation. And today I will share our works on using green lacewings in biocontrol of fall armyworm. So we know green lacewings are important predators for using in biocontrol programs in field crops, orchards, and gardens. And it is widely distributed and contains a great variety of species. Larvae and most of adults of green swings are carnivorous, and they can attack and kill large numbers of insect pests, including aphids, whiteflies, mites, skill insects, and Lepidoptera eggs and larvae. In the current next place, in the current, many natural enemy insect companies can provide green swings for purchase in the world. And I made a survey that there are about more than 10 species is available for using in North America, Europe, Australia, and Asia. The number of lacewing species available is relatively small, too small. Next, please. Since the outbreak of fall armyworm in China, we are trying to select lacewing predators for controlling it. Previous studies indicated that there are 3 species can attack and prey on fall armyworm, including these 3 species listed in the PowerPoint. But these species are not popular in China, so we need to find a local species for use in China. Okay, next, please. In China, Chrysopa pollens and Chrysopa formosa are dominant species in the field. Their larvae and adult are both carnivorous and can feed on many kinds of pests. In addition, the 2 species showed higher predation, long life, and higher fecundity. These attributes make them to be good biocontrol agents. You also can find the 2 species in Europe and other regions of Asia. Previous studies indicated that the 2 species can attack Lepidoptera eggs and larvae, such as cotton bollworm, tobacco hornworm, and Spodoptera liquora. Thus, we speculate that they may can attack and feed on fall armyworm. Next, please. So with that, we conducted predatory capacity and functional responses of grey lacewings to different stages of fall armyworm for evaluating their potential in controlling this pest. Our results demonstrated that the 2nd and 3rd instar larvae of Chrysopa pollens both had a large predation capacity to the 1st and 2nd instar for armyworm larvae, respectively. And especially for the 1st instar for armyworm larvae, there are 78 and 90 and 89 first instar larvae for armyworm was consumed by the 2nd instar and the 3rd instar larvae of Chrysopa pollens, respectively. And the pre-consumption by the 3rd instar larvae was much higher than the 2nd instar larvae of Chrysopa pollens. Next, please. The results also indicated that all stages of Chrysopa pollens showed a typical 2 functional response, and the predation capacity, the searching ability, and controlling efficacy of Chrysopa pollens 3rd instar larvae for armyworm young larvae were significantly higher than those of the 2nd instar larvae. And the 3rd instar larvae of Chrysopa pollens had a much higher attacking rate, but shorter handling time. Okay, next. As for the other species, Chrysopa formosa, our results indicated that the 2nd and the 3rd instar larvae and adult have great predation capacity when prey on for armyworm eggs and young larvae. A number of prey eaten by each stage of Chrysopa formosa increased significantly with the increase of prey densities, and then reach a plenty. you can see here, this is the larvae of Chrysopsis formosa. They attack eggs and larvae by the, you can see the photo. And next, please. The adult had the highest pre-consumption amount than the third instar larvae, but the second instar larvae of Chrysopsis formosa consumed the least amount. And the third instar larvae showed higher consumption of first instar larvae of for armyworm, while the adult and second larvae of grey leafworms consumed the highest number of eggs. Okay, next, please. The predator's functional response feature type 2 functional response as well for larvae and adult. According to all parameters of the functional response, we can see that the attack rate and the handling time of Chrysopsis formosa varied depending on ages of predator and the prey. Also, the control efficiency of adult was higher than the third instar larvae and followed by the second instar larvae of Chrysopsis formosa. Next, please. In a summary, we can see that the two species, Chrysopsis pollens and formosa, both have great predation capacity to eggs and young larvae of for armyworm eggs and young larvae, especially on the eggs and the first instar larvae. The third instar larvae and adult of grey leafworms are more effective in suppressing for armyworm. We can see that maximum impact was obtained if grey leafworms are released early in the field, when armyworm are in the egg and young larvae and at low densities. But the experiment was conducted in the laboratory, so more works needed to do in future to for biocontrol for armyworm in the field. Next, please. Okay. So we all know that leafworms play important role in biocontrol. However, one of the challenges confronted by a biological control industry is to develop an effective storage system for distribution and long-term low-cost storage of them. The occurrence of diapause offers a natural state that can be used for increasing storage period and promoting long-distance shipment of them. For this purpose, we investigated the environmental factors, including photoperiod, temperature, and diets responsible for the induction, maintenance, and termination of diapause in Chrysopsis formosa. First, we confirmed that Chrysopsis formosa diapause as pre-pupa in cocoon for overwintering. Next, please. You can see that the Chrysopsis formosa diapause as a pre-pupa. And next, please. And our result is accordance with previous studies by Volkovich in Russia. And next, please. And we then determined the species sensitive to diapause induction stimuli. The results indicated that the third instar is the most sensitive to diapause induction signals. And we also found that if the third instar larvae, we also found that diapause induction rate can be significantly increased when the earlier instar larvae and pre-pupa both exposed to short photoperiod and low temperature. Okay, next, please. And the effect of photoperiod and temperature on diapause induction was also determined. The results demonstrated that photoperiod is the major factor governing the induction of pre-pupal diapause, and temperature exerts a modulating effect. The photoperiodic response curves for Chrysopa formosa showed a typical long-day response over a wide range of temperatures. Also, the critical day length for the induction for diapause induction was estimated to be 14.3 hours at 20 Celsius, with a shift towards short day lengths at higher temperatures. And the diapause response was maximum with a short day length of 8 hours day length at 20 Celsius. And at this condition, almost all the individuals can enter into diapause. As for the diapause maintenance, we find that short photoperiod and moderate temperature can maintain diapause, and that the termination of diapause occurs gradually over a long period of time. But long photoperiod and high temperature accelerate the process of diapause development and shortened the duration of diapause. Okay, next, please. We also find that chilling temperature had a significant impact on development and termination of diapause. From the figure, you can find that diapause termination rate was highest at 5 Celsius, and the development of diapause was synchronized. And also the percentage of diapause termination at 10 Celsius was much lower than at 5 Celsius. However, in comparison at 0 Celsius, the death rate is very high. So the temperature that appropriate for diapause development and termination was between 5 and 10 Celsius. Okay, next, please. Our results also indicated that chilling exposure period also had a pronounced effect on development and termination of diapause. A chilling period of 60 days or more at 5 Celsius was sufficient to terminate diapause in most pre-pupal. But diapause development was fully completed only when diapause in pre-pupal that had been chilled more than 120 days at 5 Celsius. So an increase of chilling exposure duration synchronized the post-diapause development and adult emergence. Okay, next, please. If the time of chilling was regarded as part of diapause development, the chilling exposure did not shorten the duration of diapause development, but lengthened it in Chrysopa formosa, because low temperature could serve to help conserve metabolic reserves, slow the rate of diapause development, and increase the survival shape. So diapause insects can be maintained for a long period, such as 300 days in Chrysopa formosa. Next, please. For comparison, we also determined the effect of low temperature on non-diapause Chrysopa formosa. The results show that the grey wings cannot survive at 0 and 5 Celsius. At 10 degrees, the Chrysopsis formosa could stall for 30 days, but the emergence of the adult emergence dropped to 60%. There is no doubt that prepupal diapause in Chrysopsis formosa distinctly enhanced the low temperature tolerance. You can see that the non-diapause pupil were showed less cold tolerance. Okay, next, please.
You have 2 minutes, Dr. Lee.
Okay. Sorry. Okay, next. Next, please. Next, please. So by our experiments, we identified the environmental factors that are responsible for induction and termination of diapause and in Chrysopsis formosa, and they can stall at 5 Celsius for 60 to 300 days, and the shelf life was elevated by 10 times. So our results provide information for increase the shelf life and long distance shipment of chrysopsis for release in biological control program. Okay, next, please. Next, we will do more research on evaluating the quality and characteristics of lesbians after storage in diapause state. So we can provide information for release and application. Next, please. For measuring of release lesbians, we also did a lot of work to promote the large-scale production of these predators. In recent years, we compared the effects of different alternative diets on development and functionality of Chrysopsis pollens, formosa, and seneca. Also, the artificial diets, we developed several kinds of artificial diets for measuring of these release lesbians. Using artificial diets, we can decrease the cost for measuring of these release lesbians. Next, please. We also characterize the nutrition state of release lesbians reared on different diets, and these informations provide references for improvement of artificial diet research. Also, next, please. To improve the colonization of release lesbians after release in the field, we also did some research on the olfactory recognition mechanism in Chrysopsis pollens. So these results can facilitate the searching and locating of lesbians to prey in the field. Okay, next, please. Next, please. Based on the works we conducted before, now we developed 2 lesbian products, the Chrysopsis pollens and formosa. So the cumulative number of lesbians we cultured can reach 10,000 per year. Okay, next, please. We use these lesbians. Okay, next, please. Next, okay. These lesbians had been released and used in many cities for controlling caterpillars, aphids, whiteflies, thrips, mice on vegetables and fruits in greenhouse. So, and we also achieved good economic, social, and ecological benefits. Since the outbreak of fall armyworm in China, now we will try to use lesbians to control fall armyworm in the field. Okay, that's all. Thanks for your attention. Next, please. Okay, if you have any questions, please let me know.
Thank you so much for that presentation, Dr. Lee. That was excellent, and there's so much information. Again, I'm really struck by all these presentations, the amount of information, and I'm incredibly interested because this is from a mass rearing of predators, which is a bit different than our parasitoids before, but I'm really very interested in the breadth of research there, from exploiting that diapause stage and mass rearing to the diets to the understanding the olfactory mechanisms of the lacewing right through to the release of them. A couple of questions here.
Okay.
For the release, you have some examples there where you've produced the product, you've released it in some crops. How effective was it in those crops? I think
Well,
here you said vegetables and fruits in greenhouse.
oh,
Have you released any yet? And how effective were they?
oh, pardon me. You mean
The green
what
lacewings.
kind of vegetables?
No, I'm understanding how effective was the release of green lacewings in the field. Have you done that yet at all?
ETAO?
How effective was the green, how effective were the green lacewings in the field?
The gray, the
For your release and application, how effective?
How effective?
Effective? How efficient?
Oh, efficient?
Yep.
Yeah, it works well. You know, we mainly release wings for control aphids and caterpillars. So the population of aphids can be decreased after release twice or 2 to 3 times.
Okay, excellent. Thank you. It's my New Zealand accent, Dr. Lee. I apologize. My words don't always sound very clear.
Sorry.
No, it's me. it's my lovely Kiwi accent. I have another question. How cost effective is this approach to controlling fall armyworm in your
You mean the
opinion?
cost?
Yes. Is it expensive? Is it cost efficient?
Yeah. Since now we just do some experiment in the laboratory to evaluate the potential of green lacewings in controlling fall armyworm. But in the field, we have not yet used them to, we didn't release the green lacewings to see how what the efficiency or the impact. It's hard work. It's maybe next we will do some research in the field to to combination of the laboratory experiments result.
Excellent. Okay. One question here is, how can you ensure that released lacewings in the field remain and reproduce? Have you looked at that? How do you keep them in the field where you have released them and make sure they stay there and reproduce?
You mean
in the field?
In the field, keep them stay in the location, right?
Yes, yes.
Up to date, we just it's better to release wings in greenhouse. If in the field, it's the area is very wide, so maybe we can use some chemicals to how to say that,
to attract them.
Use some chemicals to keep them stay there.
Okay, that's interesting. Do lacewings like hunting in corn and maize crops?
I don't think so.
So will they be able to be used for fall armyworm in maize?
Oh, you mean, I see the question. Do they like hunting?
Excellent.
You can find you can find them in corn and maize crops. The population is high.
Okay.
So I think they can hunting in there.
Excellent. And there's another question, if you can see the questions, is how important are brown lacewing species? They're more common in Southeast Asian countries. Can you see
the brown lacewings?
Yep.
Since now I just the popular species is gray lithvium. I think just a few species of brown lithviums was used in the world now.
Okay.
So maybe more works needed to do to find more species of brown lithviums.
Excellent. Here's a question from Myanmar here. Which stage normally would you release in the maize field for the lacewing? Which stage of the lacewing?
I think the third instar larvae and the second or third instar larvae is better because they can stay in the field longer.
Excellent.
Yeah.
Thank you so much. And
Thank you.
it's a fantastic presentation. I'm looking forward to hearing how all that work goes in the field. Maybe in another year's time, in 12 months' time, it would be good to have an update on your work and how that goes. But thank you so much.
Okay,
it was excellent to hear. Thank you very much, Dr. Lee.
Thank you.
And I'd now like to just move on to our final session. It's just a brief summary from Fang Zhang from CABI. And Fang, if you could join us, it would be great to get your ideas on what your key takeaways are for the session. It's been a very detailed session, so I'm really keen to hear your summary.
Thank you, Alison. I also thank all the speakers for their excellent presentations. There are so many written information that I had to draw on, but from all the presentations, we can clearly see that biological control of fall armyworm has a potential, real potential. As demonstrated in China, India, and African countries, you can see that there are lots of parasitoids sitting in the field that will help us to combat the fall armyworm. So there's no panic for us, we are not working alone. So we should understand our agro-ecosystem, particularly the natural enemy complex. Of course, from all the presentation, I can also see clearly that there's a clear technical route from research to the application. So first, you need to understand, to identify the parasitoids, predators in your field. This might be right in different region and different country. So it's important for you to understand your local condition. Let's see the which species are there. And then, of course, then you can further carry on the test to select the most promising, either parasitoids or predator. To evaluate their performance in the field, in the lab, and also in the field, to try out what's the best spraying methods. And of course, in the end of the day, you need to release them in the field to demonstrate to the farmers how effective they are and how much they are, that the farmers are affordable, the products are affordable for farmers to buy and to access. With that, I think this is very important to have local production, as I mentioned in the beginning, and also all the speakers that develop appropriate local production model or method to multiply these parasitoids or predators suitable for your local conditions. I also see interestingly that some interesting research from Chinese study that dipoles. I want to really address this. Dipoles is very important. That would help us to tackle the problem. As you know, most of the biocontrol agents have shortcoming, short shelf life. That's a limit actually. The comparable with the chemical pesticides. So if we could do such kind of good research in dipoles, that would help us to increase the shelf life and to improve the biological control profile, I think. So in the end, I also borrowed the word from Alison. In the beginning, he said you develop the capacity at a local level within the country. It's very important. Yes. So I think this seminar gives lots of good ideas. and also more encourage for me to have a confidence to biocontrol. That's all.
Excellent. Thank you so much, Fang. That was, as always, a great summary, and you tied it back to that building capacity and capability within the region and at national level, which is so important. Thank you very, very much. And I would like to thank all the speakers today. Excellent presentations, really, really good. I'm going to have to go back and look at them all again and look at the recording, because there's a lot of information and learnings there to take out of today's session. I just want to remind you that our next session, we'd love to have you join us again. It will be on biopesticide efficacy, part 1, and it'll be very much on why are biopesticide trials so difficult. So it'll be very focused on tips and important ideas to help you in field trials of biopesticides. So I just want to highlight that. But once again, thank you to all of you who have joined us today. It's been a pleasure to have you. I'd like to wish everyone a happy Chinese New Year that's coming up, because we won't see you until March. So I hope that many of you have a lovely break and even get to see family if you can. Please take care and please join us next time. We do have a survey there. If you could just take maybe 1 minute just before we go, we'll leave it on for a little bit longer to answer the survey. We don't mind what you choose. We just want your feedback, and that will help us make the next sessions better. So thank you very much. And thank you very much, Dr. Lee, for that last presentation.